Welcome all. So now next conversion is delta to star conversion. As we have already seen that this is the delta network and this one is the star network. So suppose one delta network is provided and you have to convert it into star network. Now as you can see, I have marked the nodes. This is node 1, node 2 and node 3. Here also node 1, node 2 and node 3. So now what is the value of R1? Okay, so from node 1 what resistances you can see, to node 1 resistance RA and RB are connected. So R1 equal to RA into RB divided by sum of all resistances RA plus RB plus RC. Very simple. Now what is value of resistance R2? It is connected to node 2. So from node 2, two resistances are there, RA and RC. So take the product RA RC divided by sum of all resistances RA plus RB plus RC. So this way R2 can be determined. Now what is the value of R3? So from node 3, two resistances are connected, RC and RB. So take the product RB into RC divided by sum of all resistances RA plus RB plus RC. So in short I can say that resistance in star equal to product divided by sum of all resistances. Okay, so now next is convert delta network to a star network. So one delta network is provided to us and we have to determine it's the star network. Okay, it becomes easier if you draw inside delta network, if you draw the star network with resistances R1, R2, R3. Let us say this is node 1, node 2 and this is node number 3. Okay, so what is value of R1 resistance? What is value of R1 resistance? So to the R1 resistance, these two resistances are present. This 30 ohm and 60 ohm are present. So take the product 30 into 60 divided by sum of all resistances. 30 plus 60 plus 10 is 100. 30 plus 60 plus 10 is 100. So take the product 30 into 60 divided by sum of all resistances. So 30 plus 60 plus 10 is 100. So 30 into 60 divided by 100, 0 0 cancel, here 0 0 cancel. So 3 into 6, 8, 18 divided by 1. So answer of R1 is 18. Similarly, tell me what is value of R2 here. R2 is connected to node 2, to the node number 2. Two resistances are present, 30 ohm and 10 ohm. So take the product 30 into 10, 30 into 10 divided by sum of all resistances. Sum of all resistances is 100. So 30 into 10 divided by 100. So 0 0 get cancelled. So 3 into 1, 3 divided by 1. So answer is 3 ohm. So R2 answer is 3 ohm. Now similarly, what is value of R3 resistance? What is value of R3 resistance? What is value of R3 resistance? To R3 resistance, 60 ohm and 10 ohm are connected. So take the product 60 into 10 divided by sum of all resistance. 60 into 10 divided by sum of all resistances. 60 into 10 divided by sum of all resistances is 100. So 0 0 again cancel. So 6 into 1, 6 divided by 1. So answer is 6 ohm. 0 0 cancel, 0 0 cancel. So 6 into 1, 6. 6 divided by 1 is 6. So this way R2 is 3 ohm and R3 is 6 ohm. And last step is draw the circuit. Okay. R1 is 18 ohm. R2 is 3 ohm and R3 is 6 ohm. One more example for practice. Okay. Convert given delta network to a star network. So one delta network is provided to us and we have to determine the resistances of star network. So let's mark the node. So let us say this is node number 1, this is node number 2 and this one is my node number 3. This is my node number 3. This is my node number 3. Okay. So what is value of R1 resistance? So take the product 10 into 20 divided by sum of all resistance. 10 plus 20 plus 5 is 35. So 10 into 20 divided by 35, that is nothing but 200 divided by 35. Answer is 5.7 ohm. Now from node 2, what is value of R2? So take the product 20 into 5 divided by sum of all resistances. So 20 into 5 is 100 divided by 35. So answer is 2.85. Next, R3. For R3, 10 into 5, this is node 3. So 10 into 5 divided by sum of all resistances, 35. So 10 into 5 is 50. 50 divided by 35. Answer comes out as 1.42 ohm. Last step is draw the delta star network with resistances. So this one was node 1, this one was node 2, and this one was node number 3. Okay. Now one important relation we have. The relation is that if all resistances in star are same, if all resistances in star network are same, then R delta equal to 3 times R star. So resistances of all delta network will also be same, and it is nothing but 3 times resistances of star network. What I mean to say is that suppose here delta star network is given, and so let us say all resistances are of same value. Let us say 5 ohm each. All resistances are same means they have same value. For example, the value is 5 ohm each. Then all delta resistances will also be same. And what is the relation? That delta resistance equal to 3 times star resistances. So all delta resistance values will be, here 555 was there, here 5, 5, here is also 5. So all delta resistance value will be 3 times 5, means this all delta resistances will also be 3 times. So 15 ohm, 3 into 5 is 15. So 15 here, and here also 15 ohm. Then second note, what is the second note? Just let us say, just quickly we will read out. So second note is, note is, if all resistances in delta are same, then R star equal to R delta divided by 3. If all resistances in delta are same value, we know that there are 3 resistances in delta network and 3 resistances in star network. If that all 3 resistances are of same value, then resistance of star network will also be R of same value, and it is given by R delta divided by 3. For example, suppose delta resistances are 30 ohm, 30 ohm, 30 ohm. All resistances are same and are of same value, 30 ohm, 30 ohm, 30 ohm. Then star resistances will be R delta divided by 3. So 30 divided by 3 is, R resistances will be 10 ohm, 10 ohm, 10 ohm. 30 divided by 3 is 10 ohm. Let's quickly calculate. Okay, so we have this relation. What is the value of R1? 10 in 30 into 30. 30 into 30 is 900 divided by sum of all resistances. So 30 plus 30 plus 30. So that means 90. So 0 0 cancel. 90 divided by 9 is 10. So we got the R1 value as 10. Similarly, we will get the value of R2 and R3 also as 10. So this way we can convert delta network to star network by this conversion formula, and we have the relationship. If resistances are same, then R delta is 3 times R star, and if resistances in delta are same, then R star equal to 3 delta R delta divided by 3. Okay, thank you.